Hey everyone, welcome back. Today we're going to talk about concrete. We're going to talk about what it's made of, actually what it's composed of, the formwork that needs to be constructed for it, and also how to reinforce it for, giving it the strength, the shear strength, so that it doesn't break and crack on you as often. So we're going to start with um, pretty much, you need to have a solid foundation. But we're not going to talk about the soil quite yet. That's for another video. Talking about the concrete, you need to have a nice level area, obviously, that where you're going to pour, unless you're pouring like stairs or a slab on the side somehow that is anchored in some way. So just talking about the concrete itself, we're going to take a look at what it's actually composed of. Obviously you need actually cement, not concrete, but cement. And usually it's type 2 or type 5, especially here in California, unless you're in somewhere else, and then you have to look at your structural drawings and where the engineer will obviously tell you what the specs are, or inside of your specs, so you can see which type of concrete you actually need. And then after that, you need something called the pozzolan. Usually it's fly ash. Back in the day, they used to use the volcanic rock and crunched it all up and put it into the concrete. That's way back when the Romans and all them, they figured this out. So you need the pozzolan. So like I said, usually it's fly ash here, and you need the sand. And that sand is kind of technically part of your aggregate because it fills in all the small crevices that for when the pozzolan and the sand and the cement all mix together. And obviously, very important is water. Water helps in the hydration process, and the hydration process is actually where the pozzolans and the cement start forming like fingers, and that's what gives it the structural strength. Now we know that concrete has very good, well, depending on what's spec'd out, depending on what is provided, has very, very good compressive strength. What it doesn't have is shear strength. That's why you can take a sledgehammer, if you got kind of a little part of it's kind of cantilevered out and you just hit it, it'll break because it doesn't have enough shear strength. And what is actually put in the concrete in order to give it shear strength is the reinforcement bars, or rebar as we call it. Now, if you're pouring something, say at a home, like a garage, a floor, or even a driveway, you don't necessarily have to use rebar since it's kind of pretty much sitting on the level surface. Of course, the driveway is usually sloped a bit for drainage, but in essence, you can use something called welded wire fabric. And once again, there's different types you can choose. And usually the size, say like 2x2 or 3x3, 4x4, 4x3. And that just means the spacing between the little bars. And like it says, welded wire fabric means that you've got pieces of wire running in two directions, forms a lattice, and it gets welded at all the points. Now, of course, it doesn't give you as much shear strength. That is more to mitigate, separation of the pieces of concrete should there be cracks. Now, in a structural setting, you're going to use the rebar. And the rebar obviously comes in different sizes. You can get a number 3 rebar, number 4. And what those numbers correspond to is the number of eighths of an inch. So like a number 3 would be 3/8 of an inch. A number 4, since it's 4/8, it would be a ½ inch piece of rebar. And there's different grades of rebar. There's 40 grade, that's a little bit softer. And then there's a 60 grade, that's actually a little bit harder, and it's actually harder to cut. Now, what those grades actually mean is, like, grade 40 means that the shear strength of that piece of rebar is actually 40 kips, or 40,000 pounds per square inch. Obviously, the grade 60 is for 60,000 pounds per square inch of shear strength. And a lot of these things are used, like I said, in structural settings, whether it's a foundation or a wall. Sometimes, actually, especially in a wall, and you actually find it in a lot of block walls also, because since there's concrete to form the foundation of the wall, they have to have pieces of rebar to hold all that concrete together in the event, there's an earthquake, there's some shear, there's some movement, it has to stay together. But not only that, they have the pieces of rebar that are bent so that they stick up. It could be anywhere from 2 feet, 3 feet, depending on what the local code requires. And then you build up your block, and then you fill every 4, every 3, or 2, whichever one, whatever the strength that the wall needs to be. But back to the concrete. So the rebar, there's 2 different types of rebar. You can get smooth rebar, which I've seen used, but not as much in a structural setting as just to keep things from moving laterally to each other. But if you want to keep it from actually separating instead of compressing together, what you want to use is the deformed rebar, which in the center is smooth, but it's got all kinds of little bumps. Obviously, it's a certain pattern, but those bumps actually help. You got the piece of rebar like this and the little bump like that, so that when you pour your concrete over it and it tries to pull out, it has something, gives it some bite. That way it doesn't just completely rip apart. Of course, they can only stand so much, but you can vastly increase the shear strength of the concrete using that. And it also, like I said, it holds it together in the event of an earthquake, things like that. Here in Southern California, we are prone to earthquakes, and they use obviously the reinforcing bar, the rebar, when they retrofitted all the bridges. And so they added extra rebar, thicker rebar, and we have the thicker rebar now when we build the bridges here. So that's the other thing. And obviously, like I was talking about, when you do the prep work on the soil, and like I said, that's going to be a whole different video I'll do. Maybe I'll do that next time. But there's, want a nice solid foundation. But you can't just pour the concrete. I mean, if you're pouring a foundation, usually you dig the hole, you can pour the concrete straight, after you put your rebar in, you can pour it straight into the ground. But what if you're pouring a slab? The sidewalks, when you dig it all up, you can't just pour it against the earth, the little pan pretty much that you made. You have to put some formwork. Formwork can be anywhere from 2x4s, 2x6s, 2x8s. It obviously depends on the application, how the thickness, what you're doing. And that will, the thickness of the concrete that needs to be poured will dictate whether you use a 2x4, 2x6, or 2x8, or anything bigger. I don't know. It depends. If it gets very, very big, then your formwork is not only going to consist of 2x4s, 2x6s, but you're also going to have plywood. If you're building a wall, obviously you're not going to stack a whole bunch of 2x, and you're going to have all those lines that go where the 2x's meet, because since they're not actually square edges, they're rounded off, you're going to end up with lines all up and down. Now, if that's the intent of the design, that's completely different. But of course, if you want a nice, smoother finish, nice and flat, you're going to have to go with plywood. If you want a really nice finish, obviously, you want to go with like an AC or an ACX type of plywood that's nice and smooth, that's sanded on one side, or you can go with a BCX. But in most cases, if it doesn't really matter, if they're going to sack the concrete to smooth it out and take off, any of the little holes, bubble holes and everything that you can see, then you can just go with the CDX. You might get some grain that sticks to it if you don't take off your forms right away. I mean, if you don't take off your forms within a certain amount of time, you're going to end up with that wood grain showing. But if you let it start to stiffen up and it can support itself, you remove the forms, you can actually smooth some of these things out prior to it hardening to the point where you completely have to sack it. But I would really recommend, if you're pouring walls that aren't going to be covered up, I recommend that you sack the walls, which, you get some little bit of concrete glue, some water, a little bit of sand. Now you want to make sure that's industrially washed sand. Don't get any other type of sand, because it will make the job a lot harder and it might not even look as good. So you want industrially washed sand. And you mix it all together, and usually your concrete guys know how to do it, obviously, and they'll smooth it all out, do some light sanding if they need to, and fill in all the holes with that and stuff, give it a little, pretty much it's a skim coat of concrete that they're putting on that will adhere to the face of it, and it'll look very, very nice. I've seen it before. We've done it where I used to work at 2 or 3 times. Comes out very nice, especially when you have someone who knows how to do it. Now, the formwork, certain tricks to it. Obviously, the curbing gutters, when they're pouring just a small section, they do the formwork, and man, those guys that do it all the time, they form that same morning. I've seen, 4, 5, 600 feet of sidewalk torn up in the morning, formed, and poured the same day in the afternoon, where by the time the 8 hours comes up and it's time to go home, it's pretty stiff. You can walk on it. They even remove the forms by that time. Same thing with the gutters. They pour them, form them and pour. Sometimes they start pouring the first things they formed before they're even done forming the last of it. And when you have people that are experienced and know what to do, you're not gonna have to worry very much about it. Now, going back to the concrete, if you are doing a public works project, whether it's for the city, the county, or the state, chances are you're going to be using a mix out of the Green Book. And the Green Book has a lot of information that is standard for public works. Like I said, whether it's the city, the county, or the state. And they will call out a city mix. We'll start with the C, then they'll say like C2500P. And usually the P means a pea gravel, or it'll have some other suffix that will kind of give you an idea of what type of concrete that you're going to be ordering. And most of the ready mix concrete companies are very familiar with these concrete mixes, and even though you call out for that, you ask them still for a design mix. Of course, in one of my other videos, we talked a little bit about the design mix, the submittals actually video. So when we're talking about the design mix, that's what you get from the ready mix concrete, or the ready mix concrete company. And you need to make sure that you have that piece of paper that shows the design mix, the number and everything. Usually you have to submit it so that you get approval, so that they know exactly what you're using. But you need to make sure that when the trucks show up, whether it's yourself that's on the job site or the superintendent, when the first concrete truck gets there, actually any subsequent concrete truck also, you need to make sure you get the ticket and check the design mix to make sure it's the same one that they submitted, or that you submitted on their behalf of the ready mix concrete company. And because every time that you have a public works project, there will be a deputy inspector on site, especially on certain things, especially the concrete. They will be on site, and you need to make sure before you hand it over to them to check, you should take a look at the ticket before the concrete guy even starts getting ready to pour the concrete. You need to make sure that lines up exactly with the design mix that they submitted. Excuse me. So it's very, very important, because if the concrete fails, it's going to be extremely, extremely expensive to take it out, redo all the work, the formwork, because you're going to have to get rid of your formwork in order to pretty much take out the concrete, or you're going to somehow damage the formwork. You have to redo it anyways. So just like they say, an ounce of prevention beats having to do all the work, again. So take those 30 seconds to go to the concrete guy, the truck driver, get that from him, and double check it before they even get started. It will save you a lot of headaches and your superintendent, and it'll save you a lot of money in the end. So we went over the concrete, the rebar, and also, what else did we go over? The formwork. I almost forgot. Okay, concrete, rebar, formwork. Those are the major things that you really need to be careful about. One of the last things is when they're finishing. You need to make sure, that obviously the guys are kind of experienced, but you also need to make sure that you know what type of finish the concrete needs to have. Some of them have what they call shiners on the edges, where when they trowel all the way around the edge of the slab, or if it's a piece of sidewalk, every 5 feet or every 4 feet, 10 feet, whatever it is, when they want a cold joint, you need to, or just for you to trowel in a joint, you need to make sure that you know exactly what you need to provide. Some of them, call to have the whole thing troweled smooth, but I believe out on the sidewalks, they like to have like a very light broom finish, because that will mitigate slipping when it's wet, whether it's rain or just water got splashed on it from the sprinklers, anything like that. A very light broom finish will help tremendously in traction while people are walking on it. But yeah, you have to make sure the shiners of that, and also like that, the breaks in the concrete. Sometimes you need to do a cold joint. There are times I've seen when in between the two pieces or the two slabs that are being poured, they want a piece of rebar in between to hold actually the two slabs together, instead of having it all lined up inside. Because if you're just pouring a small slab, that isn't gonna have a lot of weight. It's not gonna have to bear a lot of weight. They don't put rebar in the slab or in the sidewalk piece, but they want them to hold together. So in the event there is some settling, things like that, they don't completely separate. That's why they would put pieces of rebar in it. And sometimes you have to get creative, because you can sometimes you can only pour so many lineal feet before you have to have a physical break, a cold joint between the slabs of the sidewalk. So I've seen it where they do their formwork, they drill a hole in one side, and that's where they pretty much they put like a piece of felt on the side that's being poured, and they'll push through the piece of rebar so that it stays in the slab that was poured, and then they'll take the formwork off when the time comes, but that piece will still be in there, that piece of rebar, so that when they pour the next section, that rebar is already there. It's installed and they don't have to worry about it, and it's already been held by the other one. Now, of course, you're going to have to remove that piece of felt unless you can convince the engineers or the city, however you want to do it, to leave that piece of felt there for expansion, almost as an expansion joint, which I have seen does help sometimes, but not always, depending on your area. And speaking of the different areas, there are different things for when you are curing the concrete. Somewhere is very hot, you're going to have to keep the concrete very moist. You're going to have to cover it in burlap or put water on it and put plastic over it, but you're going to have to make sure that you're constantly giving it water. That hydration process uses up the water, and if there isn't enough water, the hydration process will end and you won't get the compressive strength that you needed. It might pass the test, when they have the testing cylinder, that might pass because you close it and it's got water in it, and that will cure. Now, some of them take it right away. Some of them will leave their testing cylinders out on the job site so that it's in the same environment that as what you poured, so that it's a real, pretty much an equivalent sample as to what you poured. And in that case, if it fails, guess what? You have to take all that concrete out and do it again, which we already said, very, very expensive. So in parts where it's very, very cold, you need to keep the concrete warm, whether it's space heaters. I've seen is the extreme of pretty much building a greenhouse, so that when they pour a section of concrete, as long as that greenhouse, and they'll have heaters in there. Obviously, they're monitored. Someone's there monitoring it all the time to make sure something doesn't go wrong and there's fire, burn down the greenhouse. But what you also have to understand is that the concrete itself, during the hydration process, it's an exothermic reaction, so meaning it's going to release heat. But when it's very, very cold, even at freezing, that's not going to happen. That's not going to be enough heat to keep the hydration process going. So you're going to have to keep it warm somehow, but still put water on it so it stays hydrated for the hydration process to occur. If you pour where it's very, very cold, where it's below freezing, but the water hasn't had time to escape and it actually freezes in the concrete, the hydration process will actually just completely stop. It won't stop to the point, well, let's say it pauses. It kind of goes dormant until the weather gets warm enough for the water to melt in the concrete to continue its hydration process. But like I said, if the hydration process is allowed to continue, but there isn't enough water, you're not going to achieve the compressive strength that the concrete was designed for. So you need to be very careful about the area where it's going to be poured, especially for the international companies that do this kind of work all over the world, or even between 2 or 3 countries. Just depends. Now, to end this, I would like to say, although I'm talking about concrete, pouring concrete, things like that, as of shooting this video, which is Monday, November 16th, I had to think there for a second. Believe it or not, there's a concrete shortage. And it's not so much the concrete, but it's the cement. We just can't manufacture enough for all of the projects going on during this pandemic. Because as we know, construction slowed down for a bit at the beginning of the pandemic, but once we kind of figured some things out and we were able to figure out, the wearing the mask and the social distancing, we were able to go back to work. And so when we went back to work, there's so many projects that are still continuing right now. Like I said, even during the pandemic, that the production actually kind of went down because at the beginning of the pandemic, where everybody shut down, so did the concrete companies, the cement uh, companies. So they couldn't manufacture enough cement while everyone else was kind of in a lull. So because they had to go in a lull. So now we're facing the shortage of cement. Hopefully, this, once the new year starts, because it's the beginning of November or mid-November now. Hopefully, when the next year starts, and we'll be seeing more cement, and our projects can continue on with no more delays. If you saw my video about the 405 widening project going on here in Orange County, then here in California, then you would know I said in there that one of the bridges that they were reconstructing here, they completely tore it down now, and actually they just opened it about a month ago. And that bridge was delayed because of the fact that they didn't have enough cement to make the concrete. And they actually do have their concrete plants on site, so they can make their own concrete. But without cement, you can't. Okay. Oh, one other thing, the aggregate, you need to make sure you get a poorly graded aggregate. Wait, no, sorry, that was my fault. Your aggregate is going to be pretty much just rocks, whether it's 3/4, 3/8, anything 3/8 and below is pea gravel mix. But there's 3/4, 1 inch, inch and a half, inch and a quarter. And if you're going to be pouring somewhere kind of far from where the truck is, you're going to need a concrete pump. And make sure that if you are in charge of ordering the concrete truck, that you tell them what type of mix you're having, whether it's a pea gravel mix, a 3/4, a 1 inch, quarter, inch and a quarter, or inch and a half. Because once you get past 3/4 rock, then it's a hard rock pump, bigger pump. Okay, you got a bigger hose. It has to, since it's the bigger pump, it pumps out with more force. So you're gonna have to make sure you have enough personnel to handle the hose. All right, so that's pretty much all I have to say about the concrete. Oh, for you guys that saw the thumbnail pic before you clicked on the video, I know you noticed the stairs. There's a shot on the left of the picture that shows, pretty much concrete coming down a chute. And on the right hand side, had those cantilevered, stairs. I want to say it's from a parking garage, but I can't be too sure. I saw that picture and I was like, wow, I've seen this before and not somewhere else. But that is very difficult to do, especially when you're going up that way, because obviously there's no supports for you to actually form with or form to. So you have to start at the bottom, make your form, put in all your rebar, pour that first stair. Then once that comes up to strength enough, then you have to build your formwork on top of the stairs you just poured to build the next stairs, and so on and so forth. And I mean, I can imagine that takes a while because, usually you have 28 days for your concrete to come to strength. Now, a lot of times it comes to strength before that, but I really suggest you wait in the 28 days, especially in that type of situation where you're putting extra weight on that concrete that's down below in order to pour the next one, because you have the weight of the rebar, you have the weight of the concrete coming on it, plus the guys working it all at the same time. So you have to make sure that either yourself knows how you're doing the formwork, or there are companies that specialize in just doing structural formwork. So I would suggest, if it's something that you might not have taken on before, you might want to give them a call and see, kind of how much it would cost, because one of your mistakes might cost you in the long run more than it would have cost you to hire a company that knew what they were doing. Okay, so that's it for now for concrete. Okay, so don't forget, let me see here, I'm gonna be streaming on Twitch starting this Saturday, which would be November 21st. I'm gonna be on from 4 p.m. Pacific to 5 p.m. Pacific. Okay, I think that's actually pretty good, just because it's the weekend from 4 to 5. It's after lunch, before dinner time, kind of give you some time to do stuff, whatnot. Maybe in the future I'll be adding some more hours, or make it longer hours, different day, different things like that. But I encourage you to check out the channel. It's on Twitch. Let me put that on the screen for you again. Let me see here. Okay, one more, and we're gonna go. So this is all the, you can look for these two pictures, the one's the logo, the one's the actual picture, and that you saw. It's gonna be CPM Zone, who you're looking for. Now, I might be changing the name of this channel to match that channel on Twitch, so that way, it's all the same thing. But find me there, and you can always tweet me. And if you do end up going over to the CPM Zone, then which stands for Construction Project Manager Zone, you will see there when I live stream and things. I'll have the Twitter handle up, and I also have the email that you can send email there too in case you want something discussed live on the air. And if you log in or if you join the stream, you'd be able to ask questions, and we can pretty much have a conversation live and in person. I can answer the questions, as much as I know, and share my experience with everyone. So, to that effect, I know, right now, with everything politically going on, we're probably going to go into another lockdown. A couple of states have already gone into a lockdown. There's a lot of countries that are going into a second or even third lockdown, taking this very seriously because there's started a spike. Okay, so always, if you need to, wear your PPE, whether you're in the office, whether you're out in the field, wherever you may be. I just wish for everyone to do their part. We need to keep working. We need to, as a construction field, we need to keep this country running, right? Like I said before, society really depends on the construction industry so much, but a lot of them don't even realize it. I hear people complaining, oh, they're redoing the streets now. Would you rather drive on a street that's all fucked up with potholes and shit, or would you rather have a nice, smooth 2 or 3 days, when they tear up maybe a couple more days, a week or so, depending on how much is being done and whatnot. But that is the cost of moving forward and advancing in society. So if you ever run into anyone that complains and stuff, just let them know, hey, without us, this place would be fucking shit, all fucked up all over the place. All right? Okay, so until the next time, stay safe.